Hello, it's Mrs. Marquette. Today we're talking about 7.2, which is going to be a lot of properties of rational exponents and working with radicals. So we're going to see about 3 or 4 topics in here, but the first topic is actually really related to things that we've done in the past. So if you remember these properties of exponents, I have things over here on the left like x squared times x to the third is x to the fifth. If you remember, we take these two powers. If we're multiplying two things with the same base, I add the exponents. So 2 plus 3 is 5, so x squared times x to the third is x to the fifth. Then we have x squared to the third. If we have power raised to a power, we have x to the sixth, so we multiply those powers. So if you want to take a glance through all of these powers, make sure you remember looking at these. This is back in the factor chapter last semester. The ones to really point out, I have a to the negative m equals 1 over a to the m. That's when we have a negative in the exponent. It doesn't make the number negative. It means I'm in the wrong spot. Flip me to the bottom. Okay, so that's like x to the negative 2 equals 1 over x squared. We have x to the fifth over x squared. We subtract those two powers when the bases are the same. We also talked in class about that being the powers going to battle. So I've got 5 on the top, 2 on the bottom, so the top wins by 3. So these properties can actually be applied to rational exponents. So here, our example is 5 to the 1/2 times 5 to the 3/2. Those, again, have the same bases. So what I can do is I can add the exponents. So if I zoom in here, I've got 5 to the 1/2 plus 3/2 is 2. So 5 squared is 25. So we're going to see that all of our properties of exponents will apply the same way to rational exponents. So it's really what we've done before, but we're just going to kind of see it in a new way. So let's look here at number 1. I've got 5 to the 1/2 times 5 to the 1/4. The big thing to notice here is that our 5s, those are the same base. So I'm going to keep that base, and I can add the powers. So I do 1/2 plus 1/4. I can plug 1/2 plus 1/4 into my calculator. If you want to do that, that's fine. I can also remember that I can add fractions if they have the same denominator. So this is 2/4 plus 1/4 is 3/4. So 5 to the 3/4 is my final answer. Number 2, I've got this power outside my parentheses. So I can actually take this exponent and multiply it to each of my powers. So I've got 8 to the 1/2 times 2, and I'll put over 1 just to keep my fractions making sense. And then I've got 5 to the 1/3 times 2 over 1. And I can simplify the powers. So I've got 8 to the 1st times 5 to the 2 over 3. If I multiply across the top, multiply across the bottom. And since these bases are actually different, we can't combine them. So I'm going to leave this as 8 times 5 to the 2/3. I don't need the 1 on the 8 because 8 to the 1st is just 8. Looking at number 3, this is a very similar problem at the start. I've got a power outside the parentheses, so I can bring that in. And I'll have 2 to the 4 over 1 times negative 1/4, and 3 to the 4 over 1 times negative 1/4. This is going to be 2 to the negative 1, because negative 4 over 4, times 3 to the negative 1, negative 4 over 4. And those negative powers, remember, that means not the number is negative. That means I'm in the wrong spot. Flip me to the bottom. So this is 1 over 2 to the 1st. The 2 flips to the bottom. And 3 flips to the bottom to the 1st as well. So 1 over 2 to the 1st is 2, times 3 to the 1st is 3. So 2 times 3 is 6. Okay, so take a look at that. Number 4, again, I've got the same bases in the 7 and 7. So when I've got the same bases and different powers and a fraction, I can think about subtracting the fraction or the exponents. So I could think about 1 minus a third. So that would be 7 to the 1 minus 1/3 is 7 to the 2/3. Okay, if you need to write out 3/3 minus 1/3 is 2/3. The other way we can think about this is our powers going to battle. So I've got 7 to the first on top, 1/3 on the bottom. So 1 is bigger than a third, so the top wins, and the top wins by 2/3. It has 2/3 more in its exponent. Okay, so now I've got 12 to the 1/3 over 4 to the 1/3, all raised to the second power. We can do this a couple of ways. I could start by taking that 2 into each exponent. Since these actually have the same exponents, I can think about this as 12 over 4 to the 1/3, and then after I'm done, raise that to the second power. Okay, so 12 over 4 to the 1/3 is 3 to the 1/3, raised to the second power, and then I can multiply those powers. So I get 3 to the 2/3. I could have also brought the 2 in to each exponent and then done my dividing. Either way, I'd get 3 to the 2/3. Number 6. Again, I can do this a couple ways. I can either bring that 2 in, multiply it by the 1/3. The other thing I can actually think of here is 27 to the 1/3. That's the third root of 27 squared. The third root of 27 I can actually simplify. So you can simplify these if it's possible. I get 3 squared, which is 9. Okay, so I would take this as 27 to the 2/3 and then simplify, or you can simplify it right away. Okay, last two. Number 7. I've got 4 to the 3rd times 2 to the 3rd to the negative 1/3. Again, these have the same powers, so if I want, I can think about this as 4 times 2, which is 8, to the 3rd to the negative 1/3, and then multiply those powers. So I get 8 to the 3 over 1 times negative 1 over 3, which is 8 to the negative 1st. That negative power means I'm in the wrong spot. Flip me to the bottom, and I get 1 over 8. If I would have dealt with each the 4 and the 2 separately, I would still get 1 over 4 times 2, which is 1 over 8. And the last one in this section, 6 over 6 to the 3/4. This is 6 to the 1st, so I can think I've got 6 to the 1st in the top, 6 to the 3/4 in the bottom. The top wins, but how much does it win by? Well, 1 minus 3/4 is 1/4. So those are my properties of rational exponents. Again, it's just like properties of exponents, but we're just dealing with fractions in all of our powers. The next thing that we're going to talk about is properties of radicals. We've seen this in our square roots. So we've talked about if I have 4 square root, I can write this as 2 times 2 under the square root. I can think about the tree again. And since this is the square root, I'm looking for pairs. So I've got 2 and I've got no leftovers. Right? So we've done that before. We've also talked about like 32 under the square root can be written as 2 times 2 times 2 times 2 times 2. If you broke 32 down with the tree, that's what you would get. So here I get 2 times 2 comes out, and the leftover 2 stays, so I get 4, rad 2. What we're going to do today is really, really similar, except I might not have just a square root. Properties of radicals is just going to extend this property that if I have a times b under a radical, I can split it up, or I can put it back together, whichever works more easily. Same with fractions. I can deal with it as a fraction, or I can deal with it as a radical over a radical. But notice that this time we've got an n, which means that that could be a 3, a 4, a 5. It doesn't have to be just a square root anymore. So what I'm going to do is instead of looking for pairs, I might look for groups of 3s or groups of 4s, etc. So we'll see what that looks like. The main thing they say is you must apply the properties of radicals and rationalize all your denominators. So if I have any fractions, I do have to deal with those denominators. So looking at number 9, here, both of my power, or my roots, my nth roots are 3. So I'm going to kind of think about this as looking for groups of 3. So I can break 4 down into 2 and 2. 16 is 4 and 4. And then the 4s break down again. So this is the third root of 2 times 2 times 2 times 2 times 2 times 2. So I've got 1, 2, 3, 4, 5, 6. So now, instead of looking for pairs, I'm going to look for groups of 3. So I've got a group of 3 here, and a group of 3 here with no leftovers. So what this is equal to is one full group of 2s and another full group of 2s. And I get 4. Mathematically, what this really means is I've got 2 to the third times 2 to the third, both under third roots. The third root and the 3 cancel. The third root and the power of 3 cancel. So I get 2 times 2, which is 4. But we can think about it as looking at groups because it kind of makes more sense in our pattern. I'm going to go down the left side and do the ones without fractions first, and then we'll think about fractions. So number 3 is 54. I'm still looking for a third root. So I'm going to break this up, which is 9 and 6, 3 and 3, and then 3 and 2. So 54 under the third root is the third root of 3 times 3 times 3 times 2. So I'm looking again, groups of 3. So I've got 3 3s, but that 2 does not have its own group. So I'm going to take a full 3 out, third root of 2. And that is my final answer. Things to be aware of, this little 3 is smaller. The index is written smaller, and it's written in that little crook of the radical. If you need to write parentheses, if your handwriting's not all that good and you want to make sure I know where that 3 is, you can definitely write the parentheses there. And number 13, break up 64. If you feel like you know how to do this, try it. Pause the video here and see what you get. So I'll get 4 and 2, 2 and 2, 4 and 2, 2 and 2. So it looks like I have 1, 2, 3, 4, 5, 6. So the fourth root of 1, 2, 3, 4, 5, 6. So notice this is actually like number 9. I have the same number of 2's under the radical. The difference is this time I have a 4. So I'm going to look for groups of 4. So I've got one full group of 4, and then I've got 2 left over. So my answer will be a full group of 2's and 2 leftovers. So 2 times 2 is 4. You have to have the little 4 index written here in your answer as well, because that tells me I can't simplify that 4th root anymore because I don't have enough 2's for a group. Now we're going to deal with the fractions. So if I look at number 10, the first thing I see is I can actually, I can split this up and leave it as it is, but since these are both 4th roots, what if I actually simplified first? I think that might help us because 162 divided by 2 is 81. So I get the 4th root of 81, and then the 4th root of 81 actually simplifies. 81 is 9 times 9, 3 times 3, and 3 times 3. And I can actually already see that this is going to be a full group because I'm looking for a group of 4. So my answer is 3. I could have also plugged that one in my calculator. 81 to the 1/4 is just 3. So that's the kind of fractions ones we like, the ones that work out nicely. However, looking at number 12, I can also write this as the 5th root of 3 over the fifth root of 4, which is 2 times 2. Now, I'm looking for groups of 5, and it doesn't look like I have any, but I don't like that radical in the denominator. Okay, so think back to last chapter when I didn't have enough 2's in the denominator, I needed to add another one. But this time I need a group of 5. So I don't just need one more 2. I don't just need 2 more 2's. I actually need 3 because now I've got 1, 2, 3, 4, 5 2's. But if I put 3 on the bottom, I also have to put 3 on the top. So that's still the fifth root. And I need 3 more 2's. So on the bottom, I've got a full group, which means I've got 2 in the denominator. But then in the numerator, I don't have any full groups. So this is just the fifth root, and I can multiply 3 times 2 times 2 times 2, which happens to be 24. I can't actually simplify that fraction anymore because the 24 has a root and the 2 does not. So I can't divide when they're not like. And the last one for this section is number 14. I've got the fourth root of 7 over 8. I can break this up. So fourth root of 7 over the fourth root of 8, which is 2 times 2 times 2, if I broke this up. So I'm looking for groups of 4. This time I've already got 3, so I only really need one more. So I put one on the top, one on the bottom. Full group on the bottom. And I've got 2 and the fourth root of 14 because there are no groups in the numerator. So hopefully this looks like an extension of what you've done before. The next one is going to be like radicals. So we're getting there. We've just got 2 more topics left. Like radicals is going to kind of be like terms. So I want you to remember way back, way back, if I had 2y plus 3y, I've got like terms because they have the same variable part. So I could just add the coefficients. 2 plus 3 is 5y. So you're thinking of the y's like objects, like 2 basketballs plus 3 basketballs. The basketballs aren't going to change so that they don't become basketball squareds. That wouldn't make sense. What I've really got is 5 basketballs. Okay. So here, when I'm looking at like the third root of 2 and 4 times the third root of 2, I have actually like terms again. So I've got 1 of those, and then I've got 4 more. This is like 1y plus 4y. I can add 1 plus 4 is 5. And then what's in the radical doesn't actually change. I have the third root of 2. So looking at number 16, it's very similar. I have 6 to the 1/5 and 6 to the 1/5. Those are like terms. So then I can just say 7 plus 2 is 9. And what do I have? I've got 6 to the 1/5. Number 17 and 18, they look like I should be doing like terms, but they don't actually have like terms yet. So what I'm going to do is actually break down this 16. And since I'm looking for groups of 3, I've got a full group. So I've got 2 and then a leftover 2 minus 1 third root of 2. And now I do actually have like radicals. When I give you a problem like this, you're always going to be trying to break it down, look for like radicals. So this is actually 1 times the third root of 2, or just the third root of 2. Okay. I would pause the video and try number 18 as well by yourself, but I will continue to do it here. I'm looking for like terms, so I'm going to break down 625. That's 25 and 25. So I get 5 and 5, 5 and 5. So I've got a full group, 5 third root of 5 minus the third root of 5. When there's no coefficient, that's just a 1. And now I have like terms. Final answer is 4 times the third root of 5. Okay, so these ones, like terms, if you see a plus or minus, you're trying to add or subtract. Always look for like terms. This last section is really just everything we've already done. So you've already learned all of the new stuff. Now we're just applying it to things with variables. So I'm just going to kind of truck through these problems. I would, after we do a few, try to pause and see how many of these you can do by yourself, and then kind of fast forward through the video and see which ones you need to watch. So I'm just going to kind of go through. Here I've got the third root of 125. So I'm going to break down 125 is 5 times 5 times 5, and then we can really treat y to the 6th the same way as we treated our numbers. Y to the 6th is just 6 y's. 1, 2, 3, 4, 5, 6. It's y times itself 6 times. So if I'm looking for groups of 3, I've got a full group of 5's, a full group of y's, and another full group of y's. So my answer is 5, and then y times y, which is really y squared. Okay, so that's kind of going to be how our problems will look. When you have full groups of a variable, you can bring them out as well, just like we did for numbers. Number 20, 9u squared v to the 10th to the 1/2. Remember that we can write a 1/2 as a square root. So I can write this like so, and then I can break it down. So I've got 3 times 3, and then 2 u's, and then 10 v's. I can still write that down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now since it is a squared, square root, I'm looking for groups of 2. So I'll go ahead and circle groups of 2. So my answer, I've got a full group of 3's, I've got a full group of u's, and then I actually have 5 groups of v. So it's 3u v to the 5th. Okay, so now that you've seen a couple, I would maybe see if you can do many of these. So pause the video, try some, and then come back and see what your answers are looking like, or if you need to go over any together. Number 21, I've got the 4th root of x to the 4th, which is 4 x's, 8 y's, 1, 2, 3, 4, 5, 6, 7, 8, and circle your pairs, or in this case, your groups of 4. So I have one group on the top, 2 groups on the bottom, no radicals that I have to deal with, so I can leave it just like that. This one you may struggle with a little bit at first, because this is the 3rd root of x over the 3rd root, and I've got 7 y's. So 1, 2, 3, 4, 5, 6, 7. Now I have a full group of y's, another full group of y's, but then I've got 1 left over. So what I need to do is I need to get a full group. So I need 1 more, and actually a second one as well, because now I've got a full group. So then I've got 2 more on the top. I've got a full group of y's on the bottom, the 3rd root of x, y squared, over, and I've actually got 3 groups of y, so y to the 3rd. Number 23, here I'm actually going to think about this one in my mind. So I could either write out 5 A's, 9 B's, 13 C's, or I could think, okay, I've got a 5th root. If I wrote out everything that is a factor of 5, I just have 5 and 1, so that isn't going to have any groups. But if I think about laying out 5 A's, and I want a group of 5, I have 1 full group of A's, so A to the 1st, and I have no leftovers to put here. But if I think about the B's, I've got 9 B's. That means I've got 1 full group of B's. I actually have 4 leftovers. And then for C's, I have 13 C's sitting there, so I've got 2 full groups. And then I have 3 leftovers. So this is my final answer, ABC squared times the 5th root of 5b to the 4th c. Looking at 24, so this is kind of like one of the ones from the first topic that we learned. I'm going to look at each of my pieces separately. So I'm going to look at the numbers, like 6 and 2. And 6 divided by 2, I can reduce that fraction to 3 over 1. And then I can look at the x's. So I've got x to the first and x to the 1/3. So 1 minus a third is 2/3. So the top wins by 2/3. My y's have got y to the 1/2 and nothing on the bottom, so I can leave that as y to the 1/2. And then z to the negative 1/5. That means, hey, I'm on the bottom, flip me to the top. So I've got z to the 5th in the numerator. I don't really need the denominator since all there is a 1. So there's my final answer. Number 25, I've got a plus in the middle. So that's going to mean like terms. So I can rewrite this as x to the 5th is 1, 2, 3, 4, 5, plus 7x, x to the 3rd is 1, 2, 3, and then look for some pairs. This is a square root, so I could think about that as having a little 2. So I'm looking for groups of 2, 1, 2, and a group there. So I've got x squared, square root of x, plus 7x, and then another x comes out, so x squared, square root of x. And now I actually do have like terms. So I've got 8x squared, square root of x. This one, again, I've got a minus in the middle, so I know I'm looking for like terms, but that means I have to break some stuff up. So I can think about this as 25 and 10, 5 and 5, 5 and 2. I can see that I'm going to have a group of 3 5s. So this is the 3rd root of 2, which can't break up, minus 5 times the 3rd root of 2. So I can combine my like terms, and I get negative 4 times the 3rd root of 2. And we are almost done. Number 27, I have 5 square root of y plus 6 square root of y. These really are like terms. So I have 11 square root of y. Even though it's a square root of y, it's still the same in both terms, so I can add them together. Last one. I've got a minus in the middle, so I'm still looking for like terms. This is 3 3rd root. 5 can't break up, but I've got 1, 2, 3, 4, 5 x's. Minus x, 3rd root. 40 is 2 times 2 times 2 times 5. And then x and x. So I have a group of 3, a group of 3, and I can rewrite this as 3x times the 3rd root of 5x squared minus 2x times the 3rd root of 5x squared. So even though that was very different to start off with, there's a lot of stuff going on, I do have a huge like term right here. I've got 3 of those minus 2 of those. So I have 1 times x, 3rd root of 5x squared. Since it's only one of them, 1 times anything is just itself. So I could leave it like this. So this last page is actually really good practice for quiz or for test. I've got 2 worksheets on Blackboard that have very similar problems. So try those practice problems before you give up and just decide that there's too much going on here. Practice, practice, practice is how you're going to get better at this stuff. While you are getting used to it, write down all of your groups so that you can find those groups. Remember that this index tells you what size of group you're looking for. Come see me if you've got questions.